obviously what this slide shows, it says GIS combines spatial data from many sources. And that, again, echoes back to sharing data with people, them sharing the data with you, okay? You'll see on the image on the left, they have many different people using GIS. They're all connected to the GIS database. But who's using it? Okay, you have the water wastewater division. You've got land records, which would be like the county auditor. You have transportation, fire, police. Um, and there's a lot more than that, and we're going to see more examples of that in the end. And then on the left, there's some 3D visualizations that they're showing you. Basically, the many different types of maps that you can make, and there's plenty more than what this is. This is just a small sample. Sources of spatial data. You have digitized and scanned maps. Okay, a digitized map might be one that basically they took the old paper maps that a cartographer actually drew, and they, used a special mouse or maybe a pen to trace over those maps just to get them into the computer. Okay, when GIS first starting, that's all they had. And then they also scanned maps, stretched them, geo-referenced them accurately. But that's kind of where it started. Um, Eventually, people were able to start drawing them in, using aerial photos to reference, using survey records to actually get, or GPS even to get there it is on the map, mark it. But data can be purchased, donated, like I said, interact with people. You might be creating it, somebody else might be creating it. Databases become important. I mean, sometimes there's not a map attached to it, but still, I mean, there'll be information in those databases that you can attach. Okay, like I've done, all I have is a database, okay, that somebody has given me, but they want to get it into GIS. So, well, there's addresses there. Well, I can link it to this shapefile that's got addresses to it. Let's put these two together, and then we can make that transition. We can turn that database into a map, and with information behind it. Very powerful stuff. As I said, GPS, which stands for Global Positioning Systems. I think the point is pretty obvious. GPS does have a component a part it plays in GIS. We're not going to be able to get into that too much, but be aware of it. But this provides accurate locations, and these are used primarily in the field collection. But there's also remote sensing. Okay, those are like special satellites that are there to pick up various patterns. I mean, some of these are, for photos, but obviously also for like soil types. They'll use remote sensing for that also. And then aerial photography. Those are photographs taken from a plane, and then these photographs are taken back and geo-referenced is what it's called. Basically, we know that that point in the picture belongs to this point on the map. This point in the picture belongs to this point on the map, and so on. So GIS stores and organizes spatial data in databases, or even geo databases. Okay, so now this is what I was talking about, a attribute table. Okay, in the background you can see ArcView running and an attribute table is opened. Now, a database, an Access database, or maybe an Excel database, it doesn't look much different. Sometimes they're not easy to interpret. I mean, if they have a very spatial component to them, like an address that it's related to, that sort of thing, no, it's not easy to interpret. I mean, you couldn't just look at it and, it all makes sense in your mind as to the wheres that everything is, okay? Each individual entry or row in the table is a feature, okay? It's a particular thing on the map, okay? The data in the row is that feature's attribute data. Attribute data includes, like name, size, location, area, any relevant information to that feature. A city feature, for example, would probably include its name, population density, the demographics, number of professional sports teams, if you want, number of fire stations, anything that city, or information that pertains to that city, mayor's name, his number of years in office. I mean, just, whatever. But personally, I mean, as a rule of thumb, the more data you got in there, the better. I mean, you can always get rid of data if you don't need it, but you can't just make it magically appear, within just a few seconds. I mean, there's work going to be involved if you have to find more data. So the more, the better. Now, I've dealt with a lot of different shape files. Okay, I've never seen one with the mayor's name in it or his years in office, but, just examples. In this screenshot, you'll see the attribute table underneath, and there is a row highlighted. That highlighted row is the feature that we see highlighted on the map. So, just in this small example, we can begin to see the relationship between these attribute tables and the geographic information that it shares. You'll also see in this screenshot the identify box. That is just another way of showing the information, the same information that you would get from the attribute table, just in a list form. Now, one thing more that you can do with the data that is stored in this geographic information system, now that you're seeing all these components, these can be searched. You just maybe punch in a keyword and say, hey, I'm looking for Smith, and it would bring back everything. It would bring back names, people whose name is Smith. It would bring back streets whose maybe it's Smith Street or whatever. You could make queries. I'm looking for this certain valve made by this certain company with this certain model number installed between 1997 and 1998, and it would bring back those results. It's a very powerful tool.